started.
So welcome everybody to this month's Developers Call. Thanks all for attending. So this month it's a pretty interesting topic. I'm going to maybe a lot of hyperbole here and say it's the future of object-oriented programming in R. So we're going to be led this month by Michael Lawerence, who I guess a lot of us have already interacted. We see him here most months, and I think in fact the Developers Forum was probably Michael's idea. And there's also a lot of names on here that maybe some of us know, but we've not seen at a Bioconductor call before. So thanks very much, you guys, for attending as well. And so please take it away.
Great, thanks, Mike. I'm going to go ahead and share my screen here for the first time on this Blue Jeans thing. This goes well. All right. I am a little bit confused by this. That probably was not the right one to it. It's not. Yeah, so I'll figure this out. Just hold on a second. All right, I guess it's this one. All right, do people see me sharing something?
Blue Jeans login. Yeah, now the presentation.
All right, so now you see it. Okay. That's okay. Good. All right, I will go ahead and present this. Hopefully this will work. Does everyone see the full slide now? Right.
Yes.
All right. Yeah. So cool. All right. So I'm going to today present a proof, I guess, of this very important inequality of R7 and S3 and S4. And this is the brainchild of the people down here at the bottom of the slide, Jim Hester, Will Landau, and myself, Martin Meckler, and Liv Tierney, and Hadley Wickham. So first, we'll just get started with why is this relevant to Bioconductor. So Bioconductor is very, very much invested in S4. If you load the rtracklayer library, for example, which brings in a lot of the infrastructure packages, you can kind of do some counts. These are rough counts. Over 100 classes, over 1,000 generics, and over 6,000 methods on those generics. So, and that's just kind of in the base infrastructure, not counting all the other thousands of packages of Bioconductor. And the reason this is because S4 is essential for building an interoperable domain-specific framework like Bioconductor. It gives us the ability to have formal class definitions that have self-documenting structures. We understand the types of all of the slots, and we know that there's consistency across the objects, and you get automatic validation that enables you to trust that. And finally, you have the ability to have this multiple dispatch, which is particularly the binary dispatch of being able to have two arguments and dispatch on their interaction. That has been very useful. The problems are many. Really they're challenges to both users and developers. So a lot of times when we're developing the software, we're developing things that users are also going to be using directly, right? So we're programming in the same APIs and language, of course, as the users, and that makes it hard to find something that really kind of meets both groups' needs. And so, for example, the multiple inheritance and multiple dispatch, while powerful features, make S4 sometimes in the frameworks and the dispatch patterns hard to understand. The syntax for defining classes and in particular generics and methods is somewhat unnatural, relying on side effects. You're modifying the environment through function calls. And then there's also this lack of transparency of the object structure and of the methods that will be dispatched when you actually write your code. And so I think what that kind of hits up against one of what I see as our strengths. That is that it makes data, you might say, tactile. It allows users to kind of intuitively and directly manipulate their data, as if we're sort of clay. They want to be able to pull it apart and see the insides of it and really feel like they have command over the data. That's what R makes that really, really easy and intuitive. And S4, as at least as we tend to use it by relying heavily on abstractions and really trying to make everything opaque, I think it can sometimes run up against that, and users feel like they no longer have that transparency or that level of control. Next, well, it's not part of the base language, the methods package. So this, for example, causes some friction when we want to change, implement data structures that can be then used by base functions or other packages that are based on base and not our own system of classes and generics. And it makes it really hard to enable that interoperability across the entire package ecosystem. And also, while there is pretty good compatibility between S3 and S4, it's definitely gotten a lot better over the years. There's still certainly an awkward coexistence where you have, even in the core distribution of R, you have two different object-oriented systems, and that can confuse developers and can fragment the community. And there's also some issues with the methods implementation that probably really only matter to people like Martin and I. But that probably is one of the things that kind of set this all in motion, to be honest. So the hypothesis that we had was that there can be an extension of S3 that adds many of the important S4 features that we rely upon for this interoperable domain-specific framework without introducing yet another object-oriented system. And so what we effectively did is, maybe there's a slide missing here, but what we effectively did was to try to define an extension of S3 to enable these S4 features. And so here's some how we're going to address some of these problems and solutions. And so, for example, the complexity of multiple inheritance and dispatch, we can address that well by simply not doing those things or doing those things in an easier to understand way. So for right now, we've settled on single inheritance, and I'll have a quick discussion about the implications of that, and multiple dispatch through nested single dispatch was something that was explored, for example, in the vectors package from the tidyverse, where you will give precedence to arguments. So arguments are no longer all considered to be equal in their dispatch precedence when you're doing multiple dispatch. So you might dispatch on the first argument first, and then within that, conditional on that first argument, you then dispatch on the second, and so on. Just getting into the single inheritance question, because multiple inheritance is a very powerful tool. Once you do a lot of things, and once you lose that powerful tool, you have to find other ways of doing that, ideally coming out ahead in the end. And we can borrow a lot of ideas that come out of other languages where single inheritance isn't enforced, although those languages also have features that R doesn't have typically. So just thinking about it, though, there are some generic approaches you can take. For example, if we take this S4 vectors class compressed factor list, so this is a list of factors, but it is compressed in the sense that what we actually have is a single factor that's been partitioned into multiple elements of this list. And so this thing uses multiple inheritance and inherits from both factor list. So there could also be a simple factor list that's just implemented by an ordinary R list. And it also inherits from compressed list because it has this compressed partitioning behavior. Well, instead, what we could do is we could add to the base list class in the S4 vectors package a store slot. So this new type list store, and then you can have a simple store or a compressed store. And what you've done is you've essentially extracted the strategy of how you're actually going to store the data into its own object. And then, of course, the challenge then is, okay, well, you've done that. That's relatively straightforward. How now do you, say, implement an optimized levels method that can take advantage of the fact that you really just have one factor under the hood? And so one option for it that you can think of fairly quickly, and this has been, I've seen this used in packages, is that you can take this mangled generics approach. It's kind of like a variation on the idea of sort of nested multiple dispatch that would allow you to kind of take that store strategy and along with the data and pass it to this new generic that we define, levels underscore capital L list, which then will dispatch on that. It wouldn't even have to maybe dispatch on the factor list, but especially on that compressed store to then therefore implement that smarter strategy. So now you've said, okay, now we're in the context of this list, we're calling levels on it, and we can now dispatch on compressed store and therefore get the optimal response. And so that can be defined at the factor list level rather than requiring this multiple inheritance of compressed factor list. So that's one trick that could be used, and there are other tricks. One of which, and this is something that we could think about because we were building this framework. We can think about ways the framework could make this easier too. That's something that we probably should think about over time. So another problem that we're looking to address was around this unnatural syntax, and I'll also kind of put into this pile the complex namespace declarations, export methods, import methods, export classes, with a lot of confusion around what it actually means when I call export methods and import methods, and when I define a generic and when I don't define the generic, etc., and whether all that is even really necessary, or whether the basic namespace functionality be sufficient. So some of the solutions that we came up with, this is kind of the core of the idea in a way, is that you can construct these classes, and this is taking the code from Jim's example, where you can create this class object text, and there's no side effect here. All you're doing is constructing an object. Then you're taking that class object, which is actually itself a constructor. It's a function that you can call to create an instance of that text class. And then there's this nice simple method definition syntax where you can just use this method gets call to set a method on the generic foo for class text, being the one argument in the signature. Right, so that is the sort of crux of how these things are defined. One last problem is the lack of transparency of the object structure and methods. And so there are a couple of solutions here. I'm not sure if this has been implemented yet, but you can imagine rather than having to do a select method call, you simply call this method get, just a method function to the method gets to look up a method on the generic foo for say the class text. And so these are all just operating directly on the objects. This is not like non-standard evaluation or anything. It's just we have this foo generic object and this text class object. We're just operating on the objects. And classes can have properties, was the idea. That so now what you can do is you can say, well, I can actually expose my structure to the user. I can show them the parts of the data that they can get their hands on without breaking encapsulation, because we can at a very low level implement getters and setters for those property values. So here you have an example of a range object, let's say, with a start, end, and a length property. You can simply define the start and end as normal, like S4 slots, but then the property, the length property would be dynamic, and you'd have a getter and setter that would simply derive it from the other properties, right? And so that's one way we can kind of provide this facade or this illusion maybe of there being these simple list of slots that users can get at and manipulate without breaking our implementation or having them rely on implementation details that would make all of this more difficult to maintain and evolve. All right, so here's an idea here just at the end here around how you might try to support this problem of how do we support single inheritance and using composition. So before we had to use this levels underscore list generic. Here what we could do is maybe, it's not to support it yet or anything, it's just an idea that has been tossed around for a little while, is whether you can make that dispatch conditional on the type of a property. So you can say, I like to set a method on levels, on the factor list class, but only this method will only be called when the stores property is of type compressed store. And that may streamline method definition in those cases. And I have no idea what that would do in terms of performance and everything in the dispatch mechanism, but it's an idea that these are the types of ideas that I think we can consider when working on this sort of thing. All right, I was hoping now that maybe Jim could just kind of give a quick run through of his prototype of the README, I guess, on GitHub. Jim, are you here? Could you?
I'm here, but I had to connect from my phone because I can't.
I'll just share. I'll share the stuff like the README, and then you can. I'll give you the opportunity anyway if you want to voice over it, since you're the one that wrote it. There was.
Yeah, I can do that.
All right. Let me quickly.
So yeah. And actually, Michael, if you click on the link on the about site, if you go up and click on the link.
Which link?
Over by the about, underneath about. Yeah, there.
Okay.
The README will be here, and then there's actually a few. Made a few case studies that are a little bit more in depth. So this first example is showing sort of basic class definition for a range class that just has two properties, and the main thing to point out here is that we have this validator function that lets you that ensures that your object is a valid object. And then also we have this getter and setter syntax for the properties if you want to do something special with them. And then you can see sort of we have decent error messages for various error conditions, including if you try to change one of the properties, the validator function is ran afterwards so that ensures that you can't get a invalid object by setting a property. Okay, I think you can go down further. And then, yeah, all R7 classes have this object class attribute. So that actually retrieves the class object for whatever instance you have, which is good for introspection on the classes. And then I think Michael showed in his slides the syntax for defining new generics and methods. And so this example is showing how you would do multiple dispatch. And then the way that the next method function works is now pretty similar to the way that use method works with S3 generics. including support for like non-standard evaluation in the method call. Um, a- and also next method works the same way as the S3 version, and I guess S4 version. I don't think there's anything else to say about that other than it is working. Oh yeah, so we do have this syntax for defining an external generic. So that's a generic that's living in a separate package from the one that you're writing your code in. So there's this new external generic function, and basically this works as like a forward declaration of an external generic. So you're saying that there's a generic foo in package one that I want to define a method for, and then you actually you assign that to a value, and then you actually use the same method syntax you would as if the method was defined in your own package. The nice thing about this approach is you don't actually have to have a hard dependency on the package one in this case. So the method will only be defined if when the package one package is loaded. So basically the way that R7 does this is it sets up a hook for the namespace. So when the package one namespace is loaded, that hook is called, and then the method is registered then at runtime rather than at like install time. Okay, and then Michael, if you go back up to the top, actually, and go to the articles tab at the bar at the top, yeah. If you go to case studies, then I think that's the. So this first one is sort of derived from an example that Hadley had in his advanced R chapter for S4, and it illustrates sort of defining a class that includes both. Well, it shows off some of the setter and getter syntax again. So this person class has a name and a birth date, and the birth date. Oh, and an age. So it has a name, a birth date, and an age. And the age is actually dynamically calculated based on the birth date and today's date. And then the birth date is coerced to be a date object, both in the constructor and in the setter function. And then, so if you go down, this is just showing. Using this, it sort of works how you would expect, including has this validation function that ensures you can't pass a multiple dates for the same person, multiple birthdays for the same person, and then another class that it both inherits from a person as well as contains a boss, which is also a person. So that's showing both inheritance and composition. And again, it sort of works how you would expect. And the other one is a very simple version of sort of like a summarized experiment type class where you have a data frame that contains rows and columns property that are both data frames themselves and represent to describe what is in the rows and columns. And then we have a validation function to verify that the dimensions of these are consistent. So if you if you go down a little bit more, I just define a new generic to subset them, just to show off the syntax for defining generics and subset and methods rather. So that is just like data wrangling to get some data for the object.
Okay, here it is. All right.
Yeah. and then we see, so if you call this subset R7 generic, and then the object itself will be subset, and the rows and columns will be subset, sort of how you would expect. And again, the validation function sort of ensures that everything remains consistent. So this is definitely still a work in progress, but it already is sort of, I think, promising, and we're going to continue to work on it.
Yeah, it's looking really great so far. It's very impressive. Like it's already have reproduced a lot of the sort of essential S4 functionality in a very clean way. I'm wondering, Jim, on this when you're naming some of these basic S3 classes, like as strings instead of the actual, say, integer constructor function. I wonder if we could somehow use some tricks, if we get this integer primitive and could somehow identify the representative of the integer class, for example.
Yeah, that's actually sort of how it works right now under the hood for these basic types. Is the R7 package has it basically defines R7 classes that represent the really basic types, and then uses those for those cases. But yeah, I'm still sort of working through how that will work for other classes like S3 or S4 classes. If you want to use those type of objects in your R7 class.
Yeah, that might be a good segue for me to head on to this final slide of the this presentation. Okay, so I'll just present this again. Yeah, so I guess one of the big questions, the one we would really have to discuss in this meeting, besides just answering questions about R7, is how Bioconductor might go about adopting R7, given that Bioconductor is one of the sort of poster child for using these object-oriented frameworks to work with data. And so I guess the first point to make is that because R7 is just an extension of S3, which is itself compatible to a pretty significant degree with S4, that a lot of these things might just work. For example, R7 generics and methods should just work on S4 objects just as S3 methods do. And at least that would be something that would probably be relatively straightforward to make work. S4 classes should also be able to extend R7 classes as long as they're defined with set old class. So you can define that S4 proxy old class derivative that then once you plug the R7 classes into S4. I think the inverse one would be a little bit trickier, and I'm not sure how far along Jim is on this, but extending S4 classes with R7, which might be ideal for people experimenting with R7, because you can take the basic S4 stuff that's already been defined in the core, and then build and create your own R7 extensions of that. But I think since S4 generics require S4 classes to work, in other words, there's no equivalent of set old class. I guess you can imagine like a set new class that would allow you to define an S4 or something that the S4 generic would recognize, like an S4 class that extends S4 but isn't itself natively S4. That might take a little bit more work, but should be possible. A big thing here, of course, is serialized objects, which means that unless we come up with some really clever way of, say, auto-updating certain classes, like registering a class as being as having replaced an S4 class, then maybe there could be some kind of auto-updating that would allow you to take an old object, read it in, and then automatically convert it to the R7 equivalent object, which is actually not I don't think it would be a very big conversion. It might be as simple as just replacing that class attribute with the vector instead of just the S4 class attribute. But I mean, I think the bottom line though is that we actually control pretty much everything that we're talking about here, and so we should be able to figure out modes of compatibility to solve all these problems. I think they're all technically solvable, and we have the means to do so. So I'm fairly optimistic that we can chart out a path. I'd be happy to discuss that. So that's all I had. If anybody has any questions or you want to discuss some of these issues.
Hey, Michael and Jim, nice presentation. I guess my concern is that we're on iteration whatever of this, and I guess I was hoping probably a decade ago that we were on the ultimate, if not the penultimate one. So I'm going to go back to Thomas's request, which is that I think it'd be really helpful to get Jan Vitek or somebody of his ilk who specializes in designing object-oriented systems for computer languages to pass their eye over it and try to alert us to some of the gotchas that are going to exist in this, and make sure that we're not missing some opportunities to end up in a better spot, because I really don't want to see R8. I have to say, it's not. The differences just aren't big enough, right? And the problems, some of the ones that you've laid out are going to exist in this new system, that there's just no way out of it. That people don't read the documentation. They believe that, used to believe that object-oriented programming was invented by Java, and that was the only way to do it. And if you didn't think the way that Java thinks, then you're sort of wrong and broken. You're not going to break out of that, right? That's not going away by redesigning systems. So I don't, I think the idea that somehow this is going to transform the world, I'm a little skeptical of. A couple of other points, I think it's really important to think about, when you want to do this, if the dispatch is in any way different than what S4 is doing, which you might want it to be, then S4 and it can't coexist, because nobody can think about that the right way. And you don't have a way to say, okay, I have a whole bunch of methods that I'm using for summarized experiments, and now I'm going to put them into a new system where dispatch just works differently, right? That's just going to be insurmountable in some way. So I think that's something to be really careful about. And it might not be easy to think about having these coexist and rather have to move things over.
Yeah, certainly there's a transition state that will be a little bit difficult as people transition over and have to understand both systems. The idea being that going forward, people can build out these things in a simpler way and be free of that complexity. So yeah, it's a good point. Yeah, we've actually reached out to Jan and invited him to our meetings, and I probably have to follow up with him on that. But he's definitely welcome, and of course anybody else who has any ideas on how to fix, ensure that we don't end up with an R8. Very welcome to hear it.
I think the other big question is when the transition happens, is it going to happen from inside out or outside in? Do you start with the core Bioconductor classes and convert them to R7 relying on S4 compatibility with R7, or do you do it from the outside in relying on R7 compatibility with S4? And I think we will have to do some kind of exploration so that we can give advice to folks who are taking on these big translations.
And that's what I was trying to get at with this direction of, are you extending S4 or extending R7? Because if you're starting from the top down, then you're going to have S4 stuff extending R7 stuff, the opposite, of course, if you
Yeah,
take the
I think you
different.
sort of have to get to a setup where you're working on a more substantial problem with, bigger data, because of the other piece where I'm pretty worried about what I see is that, I think there's a real potential for performance to be pretty darn awful. And not that it can't be programmed out, right? But unless you're working on data sets that are a lot bigger than what what you have for toy examples. So what I'd try to do is find a use case that doesn't have either a well-developed system for it, and see what you can do in that. Maybe one is to try to mess around with some of the sparse matrix stuff and see whether that can be simplified, because it's an area where we would all benefit from improvement regardless, I think, and where we don't have yet well sort of established here, sort of class systems, or at least I don't think we have well established class systems in that space, and that might give you a big enough problem to work on that you'd find out about performance and clashing with both S3 and S4.
Well, the matrix package is definitely an interesting area to to see, to start to kind of chart out as a thought problem at least how would the matrix package look like in R7. Yeah, in terms of performance, I think as you say, it mostly comes down to the implementation of this. If there were things that we could do at the top level that would somehow make that implementation easier, I think it'd be a good idea. You have to get that figured out sooner rather than later. So I think that there's a lot of opportunities that to make things faster in the sort of greenfield implementation.
Sorry if I missed it, but do you have like pass by reference type opportunities here? I mean, people seem to have established their value for some things where you're pretty explicit about it.
Yeah, so right now we're only focusing on extending S3. So we're not thinking about a sort of a more message passing OOP system like the reference classes were, where you had those mutable objects. But in principle, you could, of course, have environment-based objects in this system. It just wouldn't have that. Usually, when people are looking at mutable objects, they're expecting to have this message passing syntax around them. That's not something that we've taken on yet.
I do think one thing we could or would do would be to change the R6 package to use S7, use R7 rather than S3, which would be a little tough to explain that to people, but I think that would be that would be a straightforward, unification for people who are using R6. That would just instantly fold it into R7.
Yeah. Or for simplicity, we could take some of the R6 stuff and just work it into R7, so that it's all in one place.
In principle, arranging for in principle, allowing a property to be annotated as being a reference property shouldn't be if within our current context, just create a one-cell environment for it. That should, in principle, be possible. I don't think it would require a major redesign.
Just make the semantics pretty confusing.
Robert, what happened to the idea of a sparse matrix workshop cookout? That might be a good opportunity to stick heads together and just work on this and try some new things with an eye to performance.
Yeah, just time and organization, Dirk. It is on my list of things that I really would like to get going, but there have been a couple of other things that have preempted it and taken up the time. We're a little bit worried right now about the lack of a Fortran for the M1 chip, which might be a bigger problem than anything else.
Hi everyone, Henrik here.
to Robert's point is like to finding use cases, special use cases. Has anyone looked at this from a static code inspection point of view? What you can do when you can track down and.
We haven't really been thinking about that. Are you thinking of just being able to check for problems with the static analysis or optimization or?
It's a brainstorming question, but it might help narrowing in corner cases that you don't want to have in the system, maybe going forward. I don't know if Luke can comment on that. Maybe it doesn't make sense, the question, but
yeah, I mean it's a fairly, and the nice thing about the API is that it's just using ordinary R objects. There's no non-standard evaluation going on, or say names of classes being passed around and things like that. So it seems like it's something that would be relatively easy to analyze from that perspective.
To finding dependencies to other classes and things you can do self-contained. Yep. Okay.
Yeah. Any other questions? Or?
Martin, you're muted.
Looks like Martin might have a microphone issue, I guess.
Is it better now?
Yep.
Oh, okay. So I switched from the external to the headphone. Now you understand me. So Michael was not emphasizing this so much. I think this really makes it easier to use the fact that we use arrow to define every time, right? Method with some arguments becomes class, something becomes, and if the other thing is changed, that is not changed yet, right? So Michael was asking, can we not have the integer class as an argument to method, specify the new method, rather than the string? This is also, so all this helps in some sense. It's all standard evaluation. We usually create objects by the arrow. We pass a class object by a method on that signature and so on. So that's much more intuitive than S4, where we use with strings all the time, names of classes, names of generics. Here we really pass generics, we pass classes to define new methods or new classes. This is I think it's a very, very nice idea. It wasn't mine, so I can say it.
Thanks, Martin.
I think the other idea that is really great, which I think was Michael's, is this kind of the dynamic properties with the getters and setters, because that makes it possible to kind of change the internal implementation of your object while providing a fallback for existing users. So you can kind of like deprecate properties, which seems like a really powerful tool that will make it easier to kind of more gradually transition objects in the future.
That's right. Yeah, we've always relied on, just told people to call, to call functions, accessors to manipulate objects for that reason. And this allows us to, maybe users can actually be using that at function without us being upset about it.
I think we really have embraced the fact that our users like to dive into the details of objects, and that OO system for R has to like embrace that. It can't fight the kind of encapsulation fight that other languages have by default. It just doesn't work for R. I think that's like a really interesting kind of differentiating point of OO and R compared to OO in other languages, that we see this lack of encapsulation as actually a feature, not necessarily a bug.
Right.
Yeah, I think that's a really interesting point actually. That when we do code review in our group, at least half the comments will be don't use the @ symbol when you're using bioconductor objects, right? For the more novice users, they've used a list, they use a $ to get aspects of it, and then they just want to use essentially the same syntax that feels familiar to them to use the @ symbol and dive in. And I guess, as Michael says, we've been told lots of times to always use the getters to get things out, because there's this promise that that will stay the same, but the class might change. But it's really hard to convince, I guess, intermediate users who have some level of experience that they should have this different way of interacting with these rather than the base classes. So I think that would actually be a really helpful aspect to let people use that.
Well, as soon as you get enough people are in the right places saying that if you go directly under the hood, it's a little bit faster, it's going to be out there and it'll be hard to get away from.
Whether it's true or not.
Of course.
From a more practical point of view, if I want to test it out, where do I go? There's an R7 package on GitHub or something that we can install and give it a whirl?
Yeah, that's right. We were just showing that GitHub repository. I'll just paste this into the chat. Actually, it's already been. Mike's already. You've already.
I guess I'm asking the question for anybody that watches this later, right?
Okay.
But also, I guess I was linking to the examples, but
okay.
the code is all in there too, right?
All right. Yeah, that's right. Yeah, so I guess so for the benefit of the YouTube watchers who can't see the chat, I guess I'll just quickly share my screen again so people can see it. Okay. So everyone can see this URL, right, on that we're looking at this GitHub repository.
It looks like you can find it pretty easily if you Google R7 OOP.
Okay.
R7 is not. If you just Google for R7, you get a lot of motorbikes. But if you add the OOP, you get the right place.
Cool, thanks. Right.
So I guess, do you have anything that you would really like one or more people in the bioconductor community to try and do then? Pick a class and see if we can implement it with what exists, or just brainstorm ideas, or are you open for people to join discussions on that GitHub repository and issues, or I guess how would you like to interact further?
Yes, I guess it would be great to get feedback. How should we interact? I guess there's a Bioconductor Slack, which might be a nice place to maybe set up a channel in there, right? And we can talk about how we might start experimenting with some BioC use cases. Maybe as you say, there are some candidate classes or frameworks that we could try to start porting over. We could do that within Slack. Collaborate that way. There's also this R development Slack that I'm not sure if people are even really much aware of. It comes out of our contribution working group, but it's certainly open to everybody. It's the R Devel Slack space, and that might also be a good place to start collaborating on this.
I guess I have one final question, which is, do you have any sort of timescale for when it might be incorporated into R? Indeed, I guess that assumes it's successful, the kind of working group iterations and things, but I guess it's kind of hard to persuade people to adopt it, maybe until it's definitely going to become a more standard thing. And spending a lot of time refactoring some of the core bits of Bioconductor just to find out that it's a dead end. It may be difficult to convince somebody that they want to spend that time.
Yeah, chicken and egg problem, I guess. Yeah, we're trying to build out this this package as a prototype, as a proof of concept, and something that we can do some small scale experimentation around. And once we gain some confidence that we're ready to merge this into the base language, I think we'll probably have a much bigger conversation, and make sure everyone is on board with it, and then get it in there. Yeah. Okay. Well, thanks, Mike, for having us. Be really looking forward to working with BioC, trying to see if we can kick the tires on this.
Yeah, thanks very much for the presentation. It's a really interesting topic. Hopefully, well, I certainly learned a lot. I'm sure other people in the audience did. I don't know how much you got out of us, but we're now aware of the project. I'm sure there's people that are really keen to discuss it. Thanks very much, everybody that is part of the working group that's come along too. It's really cool to hear lots of different opinions, see some different faces of these things. So thanks very much for your time.
Thanks, everybody.
Thanks, Michael.
Bye, everyone.
Bye.
Right.